Sir,
Yes.
sir, I have a doubt in the solution of the producer consume. I mean, the philosopher's problem.
What is the doubt? You tell me.
Sir, can you please share your screen?
I'll share, or you have to.
Yes, sir. No, you will share because I have a doubt in the code part.
Okay. Shall share the screen. Yes. Which part you are saying?
There in the solution 3 first part, where you retain the fieldwork function that while infinite loop, yes, here think, it will then think, then it will take the chopstick, it will eat, then it will release the chopstick. My question is, sir, this eat part, take chopstick, then sir, at eat part, I think it will be written within the test function because
No. This it will be a normal eating. It is not not required any function for this. Like a thinking, he is thinking. Here there is no requirement. Once you are getting the permission to eat here, then you can start eating. He's saying actually you are eating here by your mouth. This part.
Sort of comment, like not a function.
This is sort of comment, you can say. This is also a comment, and this is also a comment.
Okay. And sir, another doubt in the take chopstick function, there at P of Pi, you told that it will serve two purpose. If someone is eating, then it will serve as a waiting queue, or it will also counter the V of Pi part to reset it to 0. But sir, it will not act as a waiting queue, right? Because state I is set to hungry, then at test I part, any incoming process will stop if any process is there in the test part. So
no, if you are becoming hungry, if this mutex is open now, nobody is using this mutex, then you can enter here, make it hungry, yourself make it hungry, and then you specify the test function. But this test function has no such kind of blocking code. Either you will be satisfy if condition or not satisfy if condition. Yes or no? Even if you enter into this if condition, this is a V operation. In the V, there is no blocking. Am I correct or not? Only case is that after you execute the test function, there is a two choices. Either your state has changed to eating, or you are in hungry. Yes or no? So if you are becoming hungry, then you cannot go for eating or thinking. So better to wait or not.
So it will wait at the P part, not test part. Okay.
Not test part. It will wait for here because here no such a P function present here. Only you have written a V function which will be executed. Okay.
Okay, got it.
Okay. Now it is 5. We'll start within 1 minute. Huh? So tomorrow's class, some discussion related to this synchronization. Huh? Some short questions we'll discuss. If you can collect some questions from the previous year, that will be good for me. Huh? Otherwise, I will also collect something. Okay. Yes. So that we can spend one day.
Test that you will take.
Test I'll tell you.
Sir, the test that you will take syllabus.
Up to synchronization I'll ask.
Okay.
Okay, up to synchronization I'll ask. Whatever cover before that day, I'll ask up to that because it is a normal test, not so much. Okay, so we'll start now. It is 6, 9/6. So we have studied that how the lock is used. From the lock, what is the problem? Because we could not allow multiple users to enter at the same time to a certain area, which is required during this producer, consumer, or reader writer cases. Then you go for the semaphore. In the semaphore, you have studied the P and V operation. All the operations are becoming atomic, where the interrupt will not occur during that. And also you have studied the same P and V operation may create a spin lock issue or busy waiting issue. To avoid these things, we have designed another P and V operation with specifying the lock waiting queue. Okay. Once you study the P and V operation, then you have studied some classical problem. One, you have studied the producer consumer. Then you have studied the reader writer. The reader writer, you are finding multiple options. Then you go for the dining philosopher, where we look into carefully that the normal dining philosopher code, where before eating we have to take both the chopsticks as a two binary semaphore, and once you eating is over, then you have to release this both the chopsticks. So there the deadlock scenario comes into picture if everybody has taken their left chopsticks but could not get the right chopsticks. Then we go for three solutions. One solution says that maximum 4 persons to be hungry at a time or allowed to eat maximum. Then second choice, second solution, we studied that the even philosopher will go for either left chopsticks first, then right. Then the odd philosopher will take the right chopsticks, then left chopsticks, or in a reverse way. Then the third solution you have studied, unless until both the chopsticks are available, we cannot pick up it. Okay, so then you go for what is the problem again in the semaphore. Is there any issues? So there are few simple issues are there. Since this P and B operation, if you can go for the P and B operation, both are provided by the operating system, provided by the OS. Then who is using it? As a programmer or the user, okay, he is using this P and V operation. If the programmer needs a critical section, then he has to be usually use the P of S and usually use the V of S. Since this P of S and V of S is maintain a kind of lock, somebody may wrongly write, because this is written by a programmer in his own way, then sometimes the programmer may do in this way, that is some V of S then P of S. And sometimes he may do like V of S and V of S. Sometimes he may did a mistake like a P of S, then critical section, again P of S. Then it is more, this is more appropriate, but you don't ask that, sir, sometimes you are also doing it. But if you go for a locking, the locking has to be used by a P and V rather than by a V of P. Because if you make it is V, many people will be entering into this critical section at a time. There is no limit for this, since you are just making a V of S and V of S has no blocking condition. Similarly, in this scenario, if you are writing V wrongly, instead of putting P, you just write V. Then in this case also, there is no entry restriction, there is no exit restriction. And if you go for this one, the third one, there is a entry restriction, that is P of S. But while you enter into this, suppose S becomes 1, you enter, then S goes to 0, then you yourself cannot come out. Neither you come out, nor anybody can enter into the critical section. So all such kind of problems comes into picture. Then what's the solution? Because P and V will be given to us. So if P and V will be given to us, we may did a mistake. Yes, then what is the solution? The solution is, you can think in this way. Let's take your father told that you please purchase today a electrical plug point where some plugs has to be connected there. Then what you did, instead of purchasing the whole box where the all plug, switch, everything is connected, you, since you are a engineering student, you thought that it's better to purchase a separate plug, separate switch, separate wire, separate box. Then in the home you want to construct it. Yes. So while constructing the whole box, the electrical box with all these ingredients, you may did a mistake. It is not like that you don't know, but while doing it, one wire which is has to be connected with the neutral, you may connect it with the negative part. So what happens that ultimately at the end, at least some problem will become, or that switch is not properly working. Then what's the better practice? Then we will choose for another idea, that is, why don't you purchase the whole box from a company who is providing all the functionality what you need inside the box prior to that? Then that will be a good idea or not? So instead of making your own box by purchasing each ingredient and prepare it, here the ingredients are a P and V. Instead of doing it, if somebody will be provide me a box where these ingredients are already present. The P is already fixed here, B is already fixed here, only you have to write some critical section here so that it will work out. So if this kind of a box will be purchased, there is no question of a error comes into picture, because already it is there. P, wherever the P has to be fixed, it is already fixed, and wherever the V has to be written, it is already written. So if those kind of a box you will purchase, then you don't have to create any kind of issue like you have written in this scenario. Then what is this box called and who has to be provided? The operating system never likes to provide these things. Like you can say, we have studied, the operating system provides my read and write function, but the same read and write function will be used in different programming language in different way. Somewhere you are writing the printf, somewhere you are writing the system.out.println. All this println or print or printf, everything are using the same write. But whoever has used the write, I can use the write directly, or I can utilize the API provided by my programming language. In the same manner, either I can use this P and B operation directly, or I will use something which is provided by my programming language. And this kind of things is basically called as a monitor, this box. And what is this monitor? The monitor is called as a high level programming language construct, programming language construct to achieve synchronization. Yes, what in my programming language for construct means this monitor is provided by programming language. Whereas this P and V will be provided by operating system. So this monitor internally using the P and V, but one kind of a functionality kind of things will be provided to us through which you can use it. So that inside this monitor, what are the things will be present? That is the latter part we're going to study now. Okay, you can think the same thing. Hopefully you have understood, because I have to do the synchronization using the P and V, but instead of using this P and V in the raw ways, rather somebody will be provided a box where the locks are already fixed. Only I have to take a key and open the locks or close the locks. I don't have to fix it manually, because while fixing the manually, I may the knot bolt may not be tight properly, so the lock will be come out itself. So that's why what this programming language people have done, why don't you take our monitor, which consists of all this lock, you have to just use it. Yes, like in case of a structure or class and a normal C programming language. In normal C programming language, if you want to use the student information, if the structure and the class functionalities are not there, definitely you have to manually write int name, int roll number, int semester, character star name, like this. But if the same programming language has a construct like a structure and a class, then what you have to do? You don't have to worry a lot. You have to create a class, put everything there, just create a class object, and everything can be accessible automatically. In the same manner, my monitor consists of all this requirement for synchronization. I have to just use it. Then what this monitor consists of? Basically, this monitor, if you can consider this is a box, this box basically consists of a lock and some shared variable. You can use the shared variable here. You can use the atomic functions. And also you can use some condition variable, conditional variable. Okay, we'll look into this producer consumer problem. Then what are the things has to be put it here? Okay, so if you can go for this, what is the lock for this conditional variable producer consumer? You are using some full, using some empty, and at the same time you are using some mutex. with the help of these things, we are using it. Means the lock will be already there inside this monitor, which will work like a full empty or mutex, this kind of things. Then what are the shared variable you are using? The same shared variable you can use it here. I'll write down the code using this monitor. Okay. So what are the shared variable basically you are using? You are using some a of 10 where the kexts will be kept. You are using some in equal to 0 and out equal to 0 at the very beginning. That is the shared variable, because every processes those who are entering into this monitor, they have to use these things. And when they are entering, they have to go through this mutex lock, or go through this full, or go through this empty. So these are the basically locks are available. What are the atomic functions? Two atomic functions you are using, basically called as a producer, and another one is a consumer. Yes, but till now you don't know what is this conditional variable. The conditional variable is basically meant for blocking and unblocking the processes. This is used for blocking and unblocking the processes. Yes, what does it mean? What is the meaning of this? If you can consider about the producer, if you can just relate the producer is blocked with respect to my buffer size. If the buffer size is 10 is currently empty, 10 spaces are empty, or any one space is empty, then this producer will be allowed. If everything is full, then the producer cannot be allowed. Means you can say the producer, if my buffer is full, then this producer is going to be blocked. If buffer becomes empty, then definitely it is going to be unblocked. In the same manner, if you can go for another conditional variable, the conditional variable with respect to consumer. When the consumer will be go to this, if my whole buffer is currently empty, then obviously my consumer is going to be blocked. Means you can say if the data is not present, then it is going to be blocked. If the data is present, then it is not going to be blocked. Okay, so these are basically conditional variable. Later I'll tell you little more the same thing but in a different way. But please remember, my monitor, which looks like a class, you can think of it as a class in C++ or Java, which consists of some locks already exist. You have to put some shared variable like this kind of things. As for the producer consumer, you have to use some atomic function, like I have to use some producer and consumer function. These are the member variables. These are, you can say that private or static variables, and these are the member functions. And these are some conditional variable will be present. Based on the conditional variable, a process which is entering into the monitor can be blocked or unblocked. But till now you have not so clear that what is block and unblock. I have just given a simple view that the producer can be blocked, a consumer can be blocked, because there is a two kind of a processes will be enter into this monitor. When the producer enter and seeing that my total number of things are full, then definitely I can say that I have to block. Similarly, in the consumer, suppose the consumer find that nobody is present currently inside the monitor, I can easily enter because lock is open. I'll enter into this monitor, but immediately find that no data, single data is present inside the buffer. So I have to, myself has to be blocked there. Then if I'm blocking, somebody has to be unblock me. So what they're saying, what usually it is happening, a process has to be blocked himself, but the process has to be unblocked by another process. So what they're saying, a process can block himself, whereas a process will be unblocked by another process. Yes, please look into it. We have written a wrong code previously. If you have remember correctly, we have written a wrong code of the producer consumer first. when the process is going to be blocked? When my total number of cakes are equal to my rack size, then the producer is going to be blocked. Then who is activating that, waking up this producer? The consumer, which has released, taken one item or the taken one cake, then after that he has to be notified or unblocking this. Similarly, in case of a consumer case, if the consumer does not find any cake, he himself is going to be blocked. But a producer, when he's kept the first cake, he is going to be unblock that one. Okay, so that is basically called as blocking and unblocking. But we will go detail, and now you understand that what is a monitor. The monitor is basically a kind of a structure which is provided, or kind of a frame which is provided by my programming language. So different programming language provides a different kind of monitor, but the functionality of the monitor consists of few things. He has its own lock. You can keep the shared variable, you can keep the member variable, and you can also add some conditional variable to blocking and unblocking certain processes. Then what are the other restrictions of the monitor? The first restriction is that if you can say this is my monitor, he's saying only one process will be active inside the monitor at a time. Means you can say, if you can find a lock here, only one will be allowed, more than one cannot be allowed into this monitor. Okay, but why I have told that only processes will be only one processor, only one process will be will active inside the monitor at a time. Why I told that only one process will active inside this process? Because there may be also chances of more than one process. What is the reason? The reason is that, suppose this is my monitor. First a consumer comes, C1 comes. So C1 enter, because this monitor is empty, nobody is there, he can easily enter. But while it is entering, he is finding that no cakes are present. Then what will happen? He is becoming blocked. Blocked means what? He is inside the monitor, you can think of in this way, but it is not currently active. Then what happens? Another consumer also come, and because lock he has, once it will become block, then he has to be release the lock. That is also required. Otherwise, what will happen? If the consumer enter into the monitor, finding that no cake is present, he is becoming block. If he is becoming block inside this and not releasing this lock, then no producer can enter into this. Then this is a kind of deadlock which you don't want. So if a process is going to be blocked while he is entering into this monitor, then after he has to be release the lock at least. Because if he will not release the lock, another person cannot enter into this monitor. So that's why what? First C1 comes, block, release the lock. C2 again comes, block, then release the lock. Then P1 comes here. When P1 comes here, keep the cake here. After keeping the cake, then he has to be unblock one of the processes from the C1 and the C2. Then what happens? So many processes will be there, but at a time who is active at this moment? P1. Once the P1 activating this one, the P1 has to be come out, then this C1 become active at the same point. Okay, so in that way, only one process will be active inside this and others cannot be active. So let's write a normal code of the producer consumer using monitor. Then I'll go for how the state transition diagram of the monitor look like. Yes, so start with a monitor, because I told that you feel like it is a class. Okay, so if it is a class, then you are writing class X. Here also you can write on monitor producer consumer, PC. Okay, inside the monitor, what are the things are present? I told that the lock will be inbuilt. I don't have to use any lock in my own. The lock is already provided by this. But my shared variable, atomic function, conditional variable is depending upon my own choice. Because in case of producer consumer, my shared variable will be something. In case of a dining philosopher, the shared variable will be something else. So that's why what you need, as per our requirement, we have to use the shared variable and conditional variable as per our own choice. So let's say, what are the shared variable? Since I need a rack, the rack is int RAC. What is the size? The 10 is the size. Who is using this rack? Some producer and some consumer. How they are using? By one in, by one out. The in is used by producer, this in is used by the producer, and this out is used by the consumer. If you have remember, we are using in equal to 0, out equal to 0. When the producer is entering this, in will be plus plus. When a consumer is eating it, then out will be plus plus. That's why what are the other variables? I need also int in and int out. Okay. What else we need? There is a count. Why there is a count? Because count will be, remember that how many number of cakes are currently present. Then you can say that, sir, it is remembered by in. No, what is the necessity of this? In is, if in is at the 10th place, then 10 number of this are present. Am I correct or wrong? Anybody? Yes. Please think. I'm saying something wrong.
And in will be 1 or 0, right? I mean, someone is.
No. In will be gradually increasing. In is initially 0, then 1, then 2, then 3. It indicates that my producers are keeping 4 cakes. Then I told that no count is necessary to count down how many number of cakes are present. In itself will be suffice that how many number of cakes are present. Is it or something wrong? Can your in will be satisfy how many number of cakes are present?
Sir, 1 less.
No. Why 1 less is accepted? I'll write down in minus 1 is my total number of cakes, or in plus 1 is my total number of cakes. Is it will satisfy or not? Think once.
When we are dealing with consumers,
very nicely pointed. So what is saying? I am keeping the cakes 1 by 1, but now in is here. So I thought that the 4 cakes are present because it is 0, 1, 2, 3 or 1, 2, 3, 4. Not an issue. But the moment consumer eats, then out will be here. Still my in is here. So can your in will be suffice how many number of cakes are present? No. So that's why you can also take one more parameter called as count. So the count will be gradually incrementing, decrementing, depending upon that in and out. Yes, that is a choice. Are you getting? Because it is a circular queue. Yeah, then it is a circular queue. Sometimes in may be here and out may be here. It doesn't mean that only 1 cake is present. It will take 2 cakes are present. Yes or no? So that's why there is one out is also necessary. And what are the 2 conditional variable? One conditional variable where the producer has to be blocked, and another conditional variable where consumer will be blocked. So we can thought about that is a conditional variable. So condition by PR and by consumer is CR. There are 2 conditional variables. Yes. So what are the things my monitor now present? The monitor has a lock, is inbuilt lock. Yes. And he has a rack, RAC, and also he has some variable called as in and out, and also he has a one producer conditional variable and one consumer conditional variable present. So these are things are present here. Along with this, what I need also some member functions. What are the member functions? First one is init. So void init. What is the void init? It looks like a constructor. What it does, it will initialize the things. What are the things has to be initialized? Sorry, in will be initialized, out will be initialized, sir, count will be initialized. Correct or not? Yes, the init is over. Then what is the next? I want to do the producer. So what is the producer? Now we'll go for producer. What the producer does? The producer, when a certain producer has come, he has to be first check if the total rack is filled up, then I cannot keep anything. Rather, I have to go to a block state. Block state means I will block by this PR conditional variable. Are you getting my point? If the rack becomes full and a producer has entered because nobody was currently active inside this, if the producer enter, then he will check that as I have to now produce. but he is finding that the rack gets full. If the rack gets full, then the producer has to be blocked in the PR conditional variable. Based on this condition, he is blocking. Yes, are you getting my point? Then what should be the condition? The condition is very simple. That one condition you can write while this count is becoming 10 as per this code, because you have taken a rack of 10. So rack of 10, then I can write here the producer is now going to be blocked with respect to conditional variable PR. So you can say that PR dot wait. Who is executing this line? The producer himself, because the producer has entered into this code and checking that count becomes 10. Then he himself saying that I am going to be become blocked because of this PR condition. If not, if it is not, then what to do? He can easily produce an item. After producing this item, then he has to be kept. Yes. So what it does, producing item is a normal function that I'm not writing. You can say simply our function name is RAC. So RAC of in is equal to our item. He has kept this item here or the cake here. Then he is saying in equal to in plus 1, that is modulus of 10 as per this figure is concerned, then becomes count plus plus. Yes, I'm just writing first, then I'll help you all these things. Yes. Then once it is doing it here, once the producer keeping the cake inside this rack, then obviously he has to be unblock the consumer. But there are two conditions. There may be a consumer is waiting and there is no consumer is waiting. If the consumer is waiting, definitely this producer help the consumer to do something by shouting, "Hey, consumer, up, wake up, ho jaiye. Now you can get a cake. I have already kept one cake." But sometimes what happens, the producer has kept the cake and shouting, "Hey, consumer, please you wake up and do this," but there is no consumer is present. So in both cases, let's take he will shout. And how will shout? He will be shout to the conditional variable consumer, that is CR dot notify. Please look into it. Yes. If you go, since you are learning the Java, you can find a notify and wait function there. The wait is saying that I am going to wait, and notify will basically say that the certain producer or consumer through which you are making a notify, that is going to be notified. Now please look into it. Who is executing this PR code? The producer. Means the producer himself saying I am going to be blocked because of this PR condition. That's why we have written a conditional variable. A process can block himself. Yes. So the same process is saying I am going to be blocked. And another, who is executing this? Suppose he is not going to be blocked. He has kept something. Come here and telling that anybody present in the CR conditional variable, so please you wake up and do your work. Yes or no? So that he is saying about the consumer. Similarly, you can think of what should be my consumer's case. If the consumer is coming, the same idea, you can say while, then count. Tell me please, help me. Count is equal to 0. Then you can say CR will be wait. Yes, if not, then I'll take the item. So I'll take the item. I can say that I'll get the item from rack. So the rack of out, then make a out is equal to out plus 1, then modulus 10, and then I'll make a count minus minus, and then I have to shout for whom? To the producer. So the PR dot notify. So these are the basic functions which is related with each other. One is called as the wait and another one is called as notify. So these are basically related functions. So similarly for this notify, this is a wait. Okay. So in this way, then you close your class here. So this is my whole thing. Now how it is working? Yes, because this is a class, anybody can create an object. Once they will create an object, they can call a producer function, they can call a consumer function. And before creating this one, there will be an initialization function. This initialization function will be executed only once. think that when this initialization function become a static function which will be executed only once at the very beginning. Everybody cannot initialize in the same manner. So rather it will be executed only once by setting in will be 0, out will be 0, and count will be 0. So anybody calls the producer, then what is going to be happen? So what is going to be happen? Just look into it here. So I don't have a lot of space there. Okay, so I'll start here. Okay, so if anybody wants to enter into, so this is my monitor. Think that this is a big monitor. Ask.
सर अगर हम लोग अपने से लिख रहे हैं कोड तो फिर हम लोग को वो मॉनिटर की जरूरत क्या है? हम लोग तो ऐसे ही लिख रहे हैं ना, क्लास बनाते हैं।
तो ये क्लास बना नहीं, क्लास बना के लिख रहे हैं, लेकिन आप कुछ लॉक अनलॉक यहाँ लिख रहे हैं? नहीं, the same code we have written before before the actual producer consumer solution. याद है सब लोग को? कहाँ पर
काउंट 2 थ्रेड्स एक्सेस करेगा तो
कहाँ पर प्रॉब्लम आ रहा था? यहाँ पर कुछ यहाँ पर भी अप्लाई हो रहा था, यहाँ पर भी एरर हो रहा था. If the context switching will be happening here, there may be an issue. याद है?
यहाँ म्यूटेक्स लगाए थे.
हाँ, yes, very nice. You are putting some mutex and putting some p empty and v full, and here p full and v empty. Something you have written or not?
Yes.
But are you writing any kind of p and v person?
No, sir.
No, still it is going to work. So how it is working, that you are going to find out. Okay, because we are not writing anything, means this monitor is a kind of a class which is internally providing me some locking concept. And what we have already studied, only one process will be active at a time, and that monitor is assuring. The monitor will not allow more than one process to be entering into this. Yes?
सर तो फिर हम लोग वो मॉनिटर का जो वो क्लास रहेगा उसको हम लोग पास करेंगे, वो बोला ऑब्जेक्ट.
ये ऑब्जेक्ट हम जैसे हम क्लास का करते थे, किसी प्रोग्रामिंग लैंग्वेज में ऐसे हो सकता है, द मॉनिटर पीसी P1. So the P1 is the object of this, and this P1 can able to call this P1 dot producer and P1 dot consumer.
ओके सर. सर मतलब वो एक कोई ये प्री इनबिल्ट फंक्शन होगा, उसमें से ऑब्जेक्ट पास कर देंगे.
यस, नहीं, इनबिल्ट फंक्शन नहीं होगा. इनबिल्ट फंक्शन हमको लिखना पड़ेगा, क्योंकि उनको तो पता नहीं ना. डू यू थिंक दैट प्रोग्रामिंग लैंग्वेज नोज दैट what kind of code you want to write inside the DCER? No. That you have to write. Like in the class, member function you are writing or he has provided? You are writing.
मैं बोल रहा कि वो ऐसे वो इनबिल्ड रहेगा उसमें, वो जो P और V और हम लोग सिर्फ वो ऑब्जेक्ट भेजेंगे जो भी जो बनाए हम लोग.
Yes. Only you have to create an object and use it. Okay, but this is not inbuilt. Still, I am saying this part is only आपका जैसे this is a keyword which is provided by my programming language, like a class. Class a keyword which is provided by my programming language. With the help of the class and a certain syntax, I can able to write down the whole code or not.
Yes, sir.
Similarly, the same kind of features has to be provided by this. Then how it is working? Okay. So let's see. First, any producer and any consumer try to enter into this. So what is basically present? So here some racks are present. Yes, with a 0 to 9 size, and some in is present, some out is present, some count is present. This much is present. So the moment you want to enter into this, it will be enter into a state called as an entry state. Yes, anybody wants to enter into the monitor, then it has to be go to a entry state. How many processes want to enter? There may be many. That's why it is maintaining a queue called as an entry queue. Yes, how he has implemented that I'm saying. Yes, it is maintaining an entry queue. The moment the processes comes into the entry queue, he will allow one by one to enter into the monitor. Yes, how will enter? Because there will be one lock. Already it is fixed here. There is a lock kind of things will be present here. Through this lock will be go inside the monitor. When it will open, when you can go. If the lock is now available, then it will go. So if lock is available, then one of the process will be enter into this monitor, and in which state? Once it will enter, it will go to a state called as an active state. Now who is active? Only one process becomes active. Yes. So let's take first consumer has gone. Yes. Currently the shop has opened, this big shop has opened, and the consumer has entered. There are many consumers in the morning, they have reached at the front of the shop. So this monitor told that you please stand in this queue, entry queue. Then he check whether this lock is open or not. Let's the lock is open. So he take one consumer and tell that you can now enter into this shop. The moment he has entered, he is now active, means he is the current process which is going to be run this particular monitor. So while it is going inside, then what he does? He inside check that count is still 0 because nobody has entered, count is still 0. Since count is still 0, what he does? He enter into a block state by CR. So how many conditional variables are present? 2 conditional variables. Let's take one conditional variable I wrote here, and another conditional variable, that is PR, I wrote here. These are the 2 conditional variables. So when he is saying that no rack is no cakes are available here, he himself call a wait function and enter into this. So how he is calling? He is calling cr.wait. Okay, got it? cr.wait and enter into this. So after he is entering into this, very important point of the monitor is that once a process enter into a block state for a certain conditional variable, he has to be released this lock. Immediately this lock will be open. Then what happens? This entries, this particular fellow will be allow another process to enter into this. Let's take the next person is also a consumer only, C2. Then C2 again comes here. Check that it is again count is 0 because he tried to enter, check that count is 0. See one thing, when he is coming here, then he himself will block and he has to release it. They release the whole function so that this fellow can directly enter into this area, active area. Once it is active, again he is also finding count becomes 0. So he has to be called the cr.wait. Then who are coming to this CR? C1 and a C2. So where they will say, for every conditional variable, there is a conditional variable Q is present. Yes, now there is a C1 present and there is a C2 present. Okay, understood now? Then C2 also, once it is entering into this, then he has to be released this. After releasing this, let's take the next process become P1. Then P1 enter here, keep the cake, make the int to be 1, then keep the cake here, count to be 1, and after keeping it, just see, after keeping this, he has not entered to this because this condition does not satisfy, come out, checking it here, doing it here, doing it here, then cr.notify. So what it does, he is notifying, call and notify function that the CR you please notify. So the moment another process notify a certain conditional variables processes, then these processes will be come to a one more state is called as a waiting state. Waiting state. Yes, and in this waiting state, he is also maintaining a queue. What is the reason? I'll tell you one reason, that there are 2 kinds of notify is there. One is called as a notify and another one is called as notify all. If I'm writing pr.notify, only one of the processes may be notified. It may be certain rule. If it is a FCFS, then first one will be notified. If it is something priority based, then among all these waiting consumers, whoever has the highest priority, that will be notified. But if he is calling a notify all, then all the processes, those who are present in this queue, will be activated. But when they will activated, they cannot come here. Rather, they come to the waiting state. And from the waiting state, they have to go to the active state. So while coming to the waiting state, there are many people maybe wait for going to be executed. That's why they are now placed in this queue called as a waiting queue. Okay, so the moment they are coming here, one of the consumer coming here because one producer has kept something, one of the consumer is coming here, then this out of this consumer, one of this will be come here provided the lock is available. So whenever any lock will be available, then this process is now becoming active. Okay, so almost all work is finished. Then when this will be happening, if all consumers has all producers has packed this one, and one more producer has coming and no consumer is currently enter into the shop, in that case this condition gets satisfied that while count is becoming 10. If count becoming 10, then what happens? The producer himself told that I am going to wait. Yes. So once it is go to here also there is a queue, because for every conditional variable there is a queue. So there may be a P1 waiting, P3 waiting, like many people are waiting here. The moment a consumer comes, because after waiting, then it has to be released this lock. Suppose a next consumer comes. When a consumer comes, he finds that some cakes are present, because currently rack is full. So he is not enter here, rather comes here, eating, then making the out to be plus plus, making the count minus minus, then he is notifying the PR. PR means what? The processes, those who are waiting in this conditional variable, they are now wake up and going here. Okay, so this is basically this one. So how it is coming? This is coming by, that is PR.notify, and this is coming by the CR. Yes, this is the way the whole monitor state transition diagram works. Means every time only one process will be available, others are not. But sometimes what will happen, while you are making a wait, guaranteed I have to wait, because I myself that I am going to be blocked. But while the producer is notifying, it may happen that no consumer is present. Suppose in the very early morning, all the producers are coming and full the rack. But the consumers are very lazy, wake up at 9 o'clock from the hostel, and when that time what will happen? In the early morning when the rack becomes full, not a single consumer standing there. Then even if they are going to be notified, nobody is present to listen here. Okay, so that situation also happen. That's why they are saying when you call a notify function, the notify may active some processes, provided those processes are currently blocked. If no processes will be present in the conditional variable, then notify will be just like it has not called. Okay, even if you call and notify, it is going to be cancelled. Okay, so that is the purpose of this monitor. So what you have observed? We have observed that neither you have written any P and V operation, nothing. We have just written with belief or confidence that my monitor definitely put a lock here, put a lock here. How? Because he is not allowing not even a single person to become active. Now you can say, sir, sometimes here also somebody is present, here also somebody is present, here also somebody is present, and one process comes here. Then many processes are present. But out of all the processes, who is active? Only one. Either he has come from here or he has come from here. Because the lock will be managed here and the same lock has to be managed here to enter into the active state. Okay, that is the idea behind this producer consumer problem. Got it? Understood or not? This whole diagram is clear or not? Please. If not, you ask the doubts. Are you able to hear me?
Yes, sir.
Yes.
Yes, sir.
Is it okay now? You can able to write. Then I'll ask about the producer consumer, that is dining philosopher. This dining philosopher code, I think it is present in your book, but don't see the book now. So I hope you have remember the last one, which is a better one. What is the last one? If two chopsticks are available, then only I can pick up. Why the first and second is not a good choice? Why the first and second solution, what you have studied for the dining philosopher, is not a good choice? Anybody?
Any one philosopher will starve.
It may be 1. Yes, fine. Or you can say that you are putting a kind of a monopoly kind of restriction. You are saying you these 4 people only allowed. आप अभी hungry नहीं हो पाओगे. हो सकता है कभी 5 आदमी है, 5 आदमी at a time, 5 persons will be at a time hungry. Why you are restricting that the 4 will be hungry only at a time? This is not a good choice. Yes. Second one also same thing. You cannot say that before eating whether I will be take the left chopsticks or right chopstick. That is a kind of restriction you are putting. A philosopher, his mind is always free. If you put him a restriction that no, आप हर time left chopsticks पहले उठाओगे, वो मानेगा नहीं हो. वो बोलेगा नहीं मैं नहीं मानूंगा, पहले right को भी उठाऊंगा. Yes. So that's why these 2 choices. But third one is more appropriate, because you are saying if 2 are there, you pick up. Why you are, otherwise you are blocking somebody. That is a nice choice. You cannot say that no interested है, but interested है तो क्या हुआ? Others are also blocking now because of your interest. So you cannot hamper others' interest. So that's why आपका अगर 2 end में 2 chopsticks है, उठाइए, नहीं तो मत उठाइए. Yes or no? Have you remember what are the things you are using in that particular solution? Have you remember what are the variables? Please tell me.
Sir, that number of people in an array like thing where we will check it.
Yes, you are
Mutex.
you are keeping one for the philosophers.
Yes.
No. And
Yes, sir.
what else?
Sir, left,
Some
right.
states like
Some
hungry,
Very some steps. Yes. Now can you
And left, right.
yes, very nice. And one more case. Whatever the semaphore you are using there, that is a P and V, if you have remember correctly. You are using some P and V for the each philosopher. These are basically one conditional variable. Can you think?
yes,
Why? Why it will be? Because a philosopher 1 is now going to be block himself. Is it possible? A philosopher 1 is going to be block himself, but the other is going to be notified. I am going back to that code so that you can get an interest of this. Just now somebody has asked me, can you tell me this code will be executed by whom? The same people or the different fellow? Take chopsticks will be run by the same fellow who want to eat or by a different fellow? Means I am saying if the PI wants to eat, can your PI wants to call the take chopstick or somebody has to be call it?
Yeah, yes.
PI.
Yes, very nice. If the PI is calling this chopsticks here, then who will be executed this statement? PI?
Yes.
Yes.
So if I consider this is my conditional variable, this is a kind of wait or not. I am waiting or not. Why I am waiting? Because initially I took this PI becomes 0. If you have remember correctly, this all PIs become 0. So if PI becomes 0, I myself say that I have to become blocked. Yes or no? If I am become blocked, now the question next one is coming. This particular notify, this V, which is indirectly a notify, can it is always executed by the same fellow or it may be by a different fellow?
Maybe by different.
When? What is the
So
signal?
if someone is eating before,
Then how it is coming here? How this P2 will say that P1 you please go inside? कोई भी बोलता है इस कोड में?
Yes, sir. That RDL, I mean, the releasing the chopsticks.
Very nice, very nice. When he has pointed that one only, the first who has told. When you are releasing, after eating, when you are releasing, suppose P2 is going to be released now. This P2 is calling the test function or not? For whom? For the P1 and the P3 or not? This P2, when it is finishes eating and call the release function, this release function will be executed by whom? P2. But during this P2 execution, this test function will be executed by whom? P2. But this test function will be executed for which P? That is for the P1 and P3 or not? Because P2's left is 1 and right is 3. Means he is calling the test function by passing here 1 and passing here 3 or not? correct or not? By passing 1 and 3 when the P2 is executing it here. If the P2 is calling the test function, then the test function is called by passing I becomes 1. But who is calling this test function? P2. Then since P2 is executing this whole code, this line will be executed by whom? P2. For which I? For I becomes 1. Means this V function may be executed by the same fellow or maybe by a different fellow or not. Can tell me in which scenario P1 itself is saying P1? Bol paoge? P1 is going to be notify the P1 itself. Is it happening? P1 is going to be notify P1 itself.
Sir, when both chopsticks are available.
Yes, very nice. When P1 itself is hungry, come inside, going for the tech chopsticks, he is become hungry, come to the test and P1, I is 1 and P1 itself is executing this test function, then checking that my left, right, nobody is eating, then he set himself as eating, and who is executing this line? P1. And what is saying? I myself notify myself. What's the meaning? No meaning. Why it is no meaning? Because at this stage, nobody is present in this conditional variable. Because how many conditional variable? 5 conditional variable. P0, P1, P2, P3, P4. P0 or the P1 is saying himself that P1 notify to whom? To the P1. What's the meaning? P1 is currently active. Means nobody is present in the P1's conditional variable waiting queue. So that's why even if we call the notify, there will be no meaning. So what you understood? This P of Pi will be executed by ith process for ith fellow. But this V of Pi may be executed by a Pi process for the jth fellow. Yes or no? Means this wait has to be done by ourselves and notify will be done by somebody else. Why it is basically like this? Oh, it is a blocking state. It is better I myself has to be block. Otherwise क्या होगा? Monopoly हो जाएगा. Why it is a monopoly? आप कोई अगर गुंडा है, वो बोल देगा, X, आप block हो जाओ. Then मैं block हो जाऊंगा. Then what is my working principle? Nothing, no? Anybody will say shout and to me, I have to block. That is not a good way. At least if anybody shout to make him wake up, that is a good idea. But anybody shout and make me आप चुप रह जाओ, वो तो सही नहीं है ना. So this is basically चुप रहने के लिए बोल रहा है. This is basically बोल रहा है आप अभी हंस सकते हो. So this is the idea. So हंस सकते हो कौन बोल सकता है? आप खुद को बोलोगे ए हंसो. मैं नहीं हंसूंगा, अभी तो बोल रहा हूँ कैसे हंसूंगा. और कोई और एक बोलेगा आप अभी सो रहे हो, अभी उठ के हंसो. So आप उठ के हंसोगे. But in this case आप बोलोगे चुप रह जाओ. So you yourself are telling that मैं चुप रहूंगा. Yes, that is the idea. So the same thing how to write in the monitor. So what are the things are necessary? Somebody told that I need a state, I need a conditional variable. So how to write them? So the writing is very simple because you understood this now. So monitor, help me please, monitor, without seeing your book, the monitor, then let's take it as a dining philosopher, DP. What are the conditional variable? So condition of P of 5, philosopher of 5. Yes, P of 5. Yes, then what are the states? I'll create a state. So how to create a state? Enum. Then what are the states? One is thinking. Thinking. Then time हो गया. Hungry, last minute. Hungry, then क्या होगा? Eating. And what is state? सी में ऐसा लिखते ना, लिख पाओगे कि नहीं ऐसा? सी में ऐसा प्रोविजन है? Yes, provision है. So what you did? You create a state variable of this type. If you can consider this is become a type, then this is a variable for this type. So you have created. So what is the init function? Quick. Void init. क्या होगा? इसका init में
P of 5 equals to 0 होगा.
No, because here conditional variable के लिए कुछ 0 या कुछ लिखे थे? कुछ नहीं. Only you have to set that what is the initial state of each process?
Thinking.
You can write simply for I equal to 0.
लिख सकते हैं ना.
वो भी लिख सकते हो. Then I plus plus and I can write here state. एक क्यों नहीं कभी कभी लिखते हैं, कभी कभी किसी केस में क्या होता है कि ये मॉनिटर में ये इनिशियलाइजेशन अलाउड नहीं है. Yes, that's it. So this state of I becomes thinking. Yes, initially everybody is thinking. So this is my init function. Sorry, this is my init function. No need to do this. This init. Then what is the other one? Then I have to pick the chopsticks. So pick up void pick for I. Whatever how to pick up? Anybody? Please, without seeing your code. क्या करते थे pick up केस में? State को change किया.
पहले ये हंगरी करेंगे और
हाँ,
फिर
very
check
nice.
करेंगे.
हंगरी करेंगे, फिर क्या करेंगे? टेस्ट करेंगे. हाँ, टेस्ट ऑफ आई करेंगे. फिर
रिलीज करना है. लॉक.
नहीं.
Block.
ओके, थोड़ा सा वेट कर दीजिए. यहाँ पे कुछ लिखेंगे. मैं थोड़ा हंगरी टेस्ट का लिख लेता हूं तो आप बोलोगे कि यहाँ क्या है. हाँ, थोड़ा सा वेट कर दीजिए. सो void टेस्ट लिखते हैं. What is the condition? Tell me. If क्या क्या लिखते थे, थोड़ा बोल दीजिए.
State equals to hungry होगा.
हंगरी एंड लेफ्ट राइट.
And
State of
left
I
right part is not hungry.
hungry होना चाहिए. ऐसे लिख देता हूँ. And the test of left. Left मतलब आप जानते हो. हाँ, मैं ऐसे बस left लिख लेता हूँ. So the left equal to not equal to eating. याद है ना? Eating. And this test of sorry, बोल दीजिए, गलत लिख लिया. हाँ, क्या होना चाहिए? state of right not equal to it. If it is not, what you are doing? Anybody? क्या कर रहे थे इसमें?
The state को eating में change कर रहे थे.
State of I को
Eating.
I becomes eating. Then याद है कुछ नोटिफाई कर रहे थे. किसको?
Oh, we go. I mean.
ith process को.
Oh, sorry,
So
yes.
how to notify? You can say
P
the
of.
P of I dot notify. Why? Because this is a conditional variable. So with this it will make a notify. किसको कर रहे थे notify?
खुद को या
खुद को
कर रहे थे.
कहां पर wait हुआ होगा? This process will be wait where? Sir, pick. पिक में यहां पर वेट हो रहा था कि नहीं? पी ऑपरेशन कब वेट हो रहा था? कब वेट हो रहा था? थोड़ा बोलोगे इस कोड को देख के. When he was going for the wait last, I'll stop. When he is going to be wait, बोलिए.
Sir, if the state is hungry, I mean, the previous process is eating.
Very nice. Or you can say, if my state is not eating, then I will be become wait. एक नहीं? I call this test function. अंदर गया, but this condition does not satisfy. Then it will skip and come here. When he comes here, then he is going to be wait or not. Why wait? Because P of I is still 0. P of 0 means it is going to be wait. So कब wait जा रहा था? जब eating a part execute नहीं हुआ. But sometimes what will happen? I call the pickup. He is going making hungry. Call the test and all condition gets satisfied. If the condition gets satisfied, eating हो जाएगा. Eating होने पर ये क्या कर रहा है? P of I को 1 कर रहा था. Because it was 0, now it is become 1. With 1, can it is going to be wait or not wait?
Not wait.
Then you tell me in which case it is going to be wait, in which case it is not going to be wait.
When it is eating, it is not going to wait.
Yes, means now you can immediately say here that I can write this code. If our state of I is not equal to eating, then I can call a P of I dot wait. से लिखा? Is it correct? ये hungry किया, टेस्ट को चेक किया. अगर वो ईटिंग हो रहा है तो मैं वेट नहीं होगा, क्योंकि मैं खाने के लिए जाऊंगा. वेट क्यों होगा? अगर मैं यहां गया but this condition does not satisfy, then this part will not executed. If this part will not executed, मुझे eating का रोल नहीं मिला. If eating का रोल नहीं मिला, I have to go for this. Okay, and I hope you know how to drop. So void drop. Drop में क्या क्या काम कर रहे थे? 3 काम. क्या कर रहे थे? State of I को thinking. Yes, and test of left. And test of right. Finish. That's all. Yes, and at the end, close this monitor. So here, monitor close. Okay, understood? Same code or not? Same style code. But what is that? जो mutex यहाँ लगा रहे थे, mutex यहाँ लगा रहे थे, अब कुछ नहीं लिख रहे हो. Because we know that I have a confidence on this monitor that he will only allow one person to enter into this monitor. If one person allowed, then one person only pick up, execute the pickup. Another person never execute this drop. Yes, the same style, same thing. Only the crucial point of this dining philosopher is this part. If you understood this and understood this, hopefully you have understood this one. Otherwise, रट के हम लोग याद रखें. Okay, that's all today. Fine, you can leave, please leave. Time हो गया आपका. अच्छा. I'm ending, huh?
Thank you, sir.
Thank you.